This is MA 110, the second video for section 7.4. I wanted to show another way that sometimes you can solve a system of nonlinear equations. So another way to solve sometimes is by elimination. And once again, the reason I'm using this word sometimes is because as it turns out, when we have the case of nonlinear systems, it is completely possible that you may not be able to solve it using algebra or what's called analytical. There's no analytical solution to be found, so you have to use approximation techniques or graphing techniques. But again, in the problems that we usually have in our books, a lot of the times we can solve them by using substitution, or in this case, using this elimination technique. So the idea is we're going to do something that eliminates one of the variables and then solve from there. But first, I actually want to solve this graphically and figure out what my solution is going to be, and then double check it by using elimination. So I have 2x squared plus y squared is equal to 23. And that's not a circle, that's actually an ellipse of some sort. And then the next one is 3x squared minus 2y squared is equal to 17. And this is another shape, and we're interested in where are the solutions, and I can see that there are 4 solutions. There's 1, 2, 3, and 4. Those are my 4 solutions. So I'm going to solve this with elimination, and I should be looking for these 4 solutions. I also notice right away that I have some symmetry going on here, right? So I have 2.236, whatever that number is, and I have the opposite of that with a negative. So there's a symmetry, and I have this 2.236 and the 2.236, but I have negative 3 and positive 3, so there's some symmetry. And the same thing here, 3 and negative 2.236. So when I find my answers, I'm going to expect that negative 3 is going to be my x, and then I'm going to have plus or minus whatever this number is. And I'm going to have a positive 3 for an x, and I'm going to have a plus or minus whatever that answer is. Okay, so let's solve this by elimination. So I have, what I did is look at the top, and I notice that I have a y squared, and I look at the bottom and I notice that I have a minus 2y squared. So what I'm going to do is multiply the top by 2. And so I'll have a 2y squared and a minus 2y squared, and when I add them together, the y's will become eliminated out. Right? That's my strategy. Okay? So, but in order to do that, what I have to do is multiply everything on the top by 2. So I multiplied everything in the top equation by 2. 2 times 2x squared, 2 times y squared, and 2 times 23. Don't forget, when you multiply something, multiply it by everything in this equation. So I have 2 times 2 is 4x squared, 2 times y squared is 2y squared, and 2 times 23 is 46. Then I just recopied the bottom. And I recopied the bottom because now I have this nice setup where the 2y squared, when I add them together with a negative 2y squared, that'll become 0. That'll go away. So I have 4x squared plus 3x squared is 7x squared, and 46 plus 17 is 63. So I have 7x squared equals 63. So then I divided both sides by 7, and I get x squared equals 63 divided by 7. And so it turns out that x squared is equal to 9. And when I solve for x, I take the square root of both sides, and I get x is equal to plus or minus 3. Now this is great, right? Because that's what I was expecting. I was expecting that x was going to be 3 or negative 3, right? And that's what I have. X is equal to 3 or negative 3. So I start with the negative case first. If x is equal to negative 3, so I go back to my system, and if x is equal to negative 3, wherever I see x, I put a negative 3. So 2 times negative 3 squared plus y squared, 3 times negative 3 squared minus 2y squared. And I do that, so I get 2 times negative 3 squared. So this is 9 when I square it. 2 times 9 is 18. This is 9 when I square it. 3 times 9 is 27. So I end up with this 18 plus y squared equals 23, and 27 minus 2y squared equals 17. I solve them both for y squared, and I get y squared equals 5 and y squared equals 5. So how did I do that? Well, I took y squared, I left it alone, and I subtracted 18 from both sides, and I get 5. And I subtracted 27 from both sides, and I get negative 10. And then I divide both sides by negative 2. Negative 10 divided by negative 2 is positive 5. So I have y squared equals positive 5 and y squared equals positive 5. And then I take the square root of both sides, and I get plus or minus the square root of 5 and plus or minus the square root of 5. So that tells me that my x and y is minus 3 minus root 5 and minus 3 positive root 5. And look, that's what this one is over here, I bet. So let's check it out. What is the square root of 5? Well, the square root of 5 is 2.236, and that's what these points are, right? 2.236. This is an approximation of square root of 5. So I found these two left-hand points. So now I'm going to look for the right-hand points. What if x was equal to 3? Well, notice when I plug in x is equal to 3, or if I plugged in x is equal to negative 3, because I'm squaring that quantity, I'm going to end up with the same situation as I did before. This 18 plus y squared equals 23 and 27 minus 2y squared equals 17 is exactly what I had before when I plugged in negative 3, because negative 3 squared is the same thing as 3 squared. So I'm going to end up with y equals plus or minus root of 5, y equals plus or minus root of 5. So now that's the other side. This is the plus 3 and then plus or minus root of 5. So those are my 4 answers. So you can see we can solve by graphing. We can sometimes solve by substitution, and sometimes we can solve by elimination. Now I'm going to leave it up to you which way to solve, and you pick the best that works for you. And maybe it's graphing, maybe it's substitution, and maybe it's elimination. But I'll leave that up for you to figure out how to do it.